In this video, we're going to look at an application of the second fundamental theorem of calculus. And what we're asked to do is compute the derivative of the integral from x to 3x cubed of sine of t dt. So what we're doing are inverse processes because the integral involves the antiderivative, but then we're taking the derivative. So the fundamental theorem of calculus gives us a nice shortcut for that. First thing we're going to want to do, though, is split this into two. So we're going to be taking the derivative of, I'm going to split my integral from x to some point in between x and 3x cubed. A is just some constant. Sine of t dt plus, now we're going to go from a to 3x cubed sine of t dt. Oh, and we're taking the derivative with respect to x of both parts. So let's do that. Now, the second fundamental theorem of calculus we know is very straightforward as long as the x is on top. So what we're going to do is we're going to switch those limits by making the integral negative. That's one of our properties of integrals. It's going to go from a to x of sine of t dt. In this one we already got the x on top, so we'll leave it as is, a to 3x cubed sine of t dt. Now, we could go ahead and find the antiderivative, plug in the limits, and then take the derivative, but we know, based on the fundamental theorem, that if we take the antiderivative and then take the derivative back, what we're going to end up with is a negative sine of x. Because sine of a is just a constant, when we take its derivative it'll be 0. So this is for this first part here. The second part, we know we're going to have sine. Now, here we've got to be careful because we have a 3x cubed. So that's going to go in for the input of sine. And because this would be a chain rule, we got to multiply by the derivative of the inside, 9x squared. So there is the derivative of this integral function.